RISCWare is a plug-and-play, modular and auto-configurable robotic platform. In order to demonstrate adaptive, modular and robust capabilities of the RISCWare, 10 experiments were carried out on RISCBot 2. Different sensory devices, actuation platforms and software services can be selected to demonstrate desirable and optimal behavior. This experiment demonstrates manually driving RISCBot 2. Robot can be controlled by a human to move in any direction at initial speed factor of 2. User can also make adjustments to the speed factor. This experiment is similar to experiment number 1. In addition to manual robot control interface, laser rangefinder is selected as a sensory module. From the video, it can be observed that the addition of laser rangefinder does not impact the behavior of the robot. In this experiment, RISCBot 2 is under semi-autonomous control. Like in the previous experiments, a user can still control the robot, but the user is assisted by laser rangefinder. Laser rangefinder is capable of detecting obstacles at a height of 0.9 meters, and can use this information to navigate and avoid obstacles using potential field algorithm. Also, a wireless camera is active on the robot, allowing a remote operator to effectively control RISCBot in difficult-to-navigate terrain. RISCBot 2 is under complete autonomous control in this experiment. Laser rangefinder, which is capable of detecting obstacles at a height of 0.9 meters and at a distance of 6 meters, is used as the primary sensor for detecting obstacles. Robot is avoiding obstacles using potential field algorithm. Speed factor has been set to 2. This is to allow robot to be agile and allowing it to use all directions for obstacle avoidance. Like the previous experiment, RISCBot 2 is under autonomous control in this experiment. Speed factor has been increased to 3, allowing the robot to cover much greater distance in short periods. Also, 2 directions, namely front left and front right, have been disabled. This is to demonstrate the configurability of the framework. Like the previous experiment, this experiment demonstrates the configurability of RISCWare framework. 3 directions, namely front left, front right, and front has been disabled. This causes the obstacle avoidance algorithm to command the robot to spin around its own axis. In this experiment, RISCBot2 is fully under autonomous control. An array of ultrasonic sensors is used to detect obstacles. These sensors are capable of detecting obstacles at a height of 0.7 meters and at a distance of 3 meters. Speed factor has been set to 2, unlike laser rangefinder that was used in the previous experiments. The refresh rate of ultrasonic sensors are low. This experiment also uses the potential field algorithm to detect and avoid obstacles. In this experiment, 2 object-detecting sensory devices, namely laser rangefinder and an array of ultrasonic sensors, are used. This allows the fully autonomous robot to detect object at the height of 0.9 meters and 0.7 meters. To fully utilize the capabilities of the sensory modules, the concept of sensor fusion is applied. This allows the obstacle avoidance algorithm to selectively use the obstacle data to determine a much more optimal avoidance route. Demonstrated results of this experiment are better than all the previous experiments involving obstacle avoidance using potential field algorithm. In this experiment, sensor fusion of data from laser rangefinder and ultrasonic sensors, along with a video feed from Microsoft Kinect, is demonstrated. Video feed from Kinect is used to detect human faces as the robot moves around. Up to 4 human faces can be detected by the robot from the video feed. This human detection capability can be used to further improve robots' human interactions if needed. In this experiment, RISCBot2 is controlled over the web by a human using a smartphone.